So for our last video on 3.1, these are all going to be word problems, okay? And I know sometimes people panic when they see word problems, but they're really okay. Generally speaking, the point that you're looking for with these quadratic functions is going to be the vertex or the x-intercepts. Okay, so I'm going to encourage, once you get your quadratic equation, that you make a little sketch. It does not have to be perfect, but make a little sketch. If the problem talks about finding the maximum or the minimum, you're looking for the vertex. So you're going to be finding this vertex. Remember, to find a vertex, you do negative b over 2a. That gives you the x value. And then once you have that x value, you plug it back into the quadratic and you get the y value. Okay? Or you're going to be looking for where the graph hits the x-axis. Okay? And remember, to find those, you're going to have a quadratic equation. You're going to have, ax squared plus bx plus c, and you're going to want it set equal to 0 because these are the x-intercepts, and x-intercepts are where the graph hits the x-axis and has a y value of 0. Okay? All right, so let's look at some examples here. Dawes has 400 feet of fencing available to enclose a rectangular field. Okay, so I'm going to draw a little rectangle. This is his field. He has 400 feet of fencing to enclose it. That means the perimeter, the distance around, is 400. Now, two of his sides, I'm going to call these widths, and two of the sides are going to be lengths. Okay? So I don't know how long the widths are and the lengths are, but I know that they each match. Okay? And they want to know the maximum area that can be enclosed. Okay, so even though I don't see a quadratic equation, I'm probably going to be looking for the vertex of it because they talk about maximum. So this ought to be a parabola that's opening down, and we're trying to find the high point. Okay? All right, but before we do that, perimeter is add up all the sides. So 2 of the L's plus 2 of the W's, when you add up all the sides, is supposed to equal 400 because that's how much material he has to go around. Now, I also know that area of a rectangle is length times width. Okay, this is where my quadratic is going to come from. You'll see that in just a second. But 2 lengths plus 2 widths is 400. So I'm going to pick one of these to solve for. I'm just going to get L by itself. So I'm going to subtract 2W on both sides. So 2L is negative 2W plus 400. And when I divide by 2, L is negative 2 divided by 2 is negative 1, so negative W. And then 400 divided by 2 is 200. Okay, so the area is whatever the length is times the width. So here's what I know. The length is negative W plus 200. And then the width is just W. So what happens is my area is negative W squared plus 200W. That's the area. This is a quadratic, and I'm trying to find the maximum of it. Now, if you notice, instead of X and Y, we've got W's and A's. So where the X normally is, they have W's. So the width is on the X-axis, and my area is on the Y-axis. This is going to be a parabola shape, and it's opening down. So if I graph this, I would get a picture like this. So what happens is, as my width gets a little bit bigger, for a while my area gets bigger. But I reach this kind of turning point where if I keep increasing my width beyond that, the area is actually going to decrease. Okay? If you think about it, let's say that I made a rectangle that measured 1 unit by 199 units, because if I add all those up, that would add up to 400, and that would be his fencing. But the area is 1 times 199, so the area would be 199. On the other hand, if he made each side 100, his perimeter is 100, but his area would be 100 times 100, which is like 10,000. So that's a much larger area. So we're looking for the combination of length and width that gives him as big an area as possible. Okay? And that's what this is. As our width increases, for a while the area will get bigger, but eventually if I keep increasing it, my area starts going back down. Okay? So I'm trying to find the vertex of this quadratic equation. Okay, well, to find the vertex, we do negative b over 2a. So my b value is the 200, so negative 200 divided by 2 times negative 1. So that'll be a 100 when you work that out. Okay. So when my width gets to 100, that will cause the biggest possible area on my graph. So I want to find the area when I put 100 for width. So negative 100 squared plus 200 times 100. I can type that in my calculator. And I get 10,000. So it turns out that this picture where each side was 100 is what caused that to happen, okay? So their question was, what's the maximum area that can be enclosed? The max area is 10,000 square feet, because they told us they were measuring in feet. Now, if they went one step further and said, what is the maximum width that would produce that area? The maximum width would have been 100. But they only asked about the area, not the width. Okay. Number 11 is very similar. 2,000 meters of fencing. He's going to enclose a rectangular plot, but it says it borders on a river. So here's my river, and I put my plot right next to it. So notice he only has to enclose 3 sides. He's got a width, and a length. Okay, but he has 2,000 meters to use. So his length plus his 2 widths equals 2,000. So his length is negative 2W plus 2,000. So when we want to calculate his area of length times width, the length we can put in negative 2W plus 2,000 times whatever his width is. Distribute the W, and we get negative 2W squared plus 2,000W. That's our quadratic. Okay, that has our W squared. So if I graph it and I put the width on the x-axis and the area on the y-axis, our A value is negative, so it's going to open down. And same thing is going to happen as number 10. For a while, as you increase the width, the area will get bigger. But there's a magic point that if you keep increasing the width, your area will actually decrease. So how do we find this maximum spot? They said, what's the largest area that can be enclosed? So we're looking for the vertex. And vertex is negative b over 2a. Our b value is 2,000, so negative 2,000 divided by 2 times negative 2. Let's see, 2 times negative 2 is negative 4, so negative 2,000 divided by negative 4 is 500. So 500 is the width that will create the biggest possible area. And their question was, what is that largest area? So the largest area happens negative 2 times W. We know that W value is 500 plus 2,000 times W. W is still 500. So negative 2 times 500 squared plus 2,000 times 500. And we get 500,000. I guess once you knew the area, the width was 500, you could have come back over here and said, negative 2 times 500 is negative 1,000 plus 2,000 would be 1,000. The length would have been 1,000. And then so you would know your length and width, and you could have multiplied those together to get your area. But the max area is going to be that 500,000 meters squared. That's the biggest area he can make if he's got to use 2,000 meters of fencing. Okay. Another example here. A ball is thrown vertically upward from the top of a building that's 96 feet tall with an initial velocity of 80 feet per second. The distance S, so S right here stands for distance. The distance in feet of the ball from the ground after t seconds is right here. So T stands for time in seconds. Okay, don't worry about how this formula was created. We're just going to take their word for it. But they're telling us that in this formula, or this equation right here, T is the time that goes by, and S is the height, or the distance. So in other words, when you first throw that ball, he's standing on top of a building, and he throws the ball. And the ball's going to go up, and then it's going to come back down. Okay? And so this equation right here says as time goes by, how high is the ball? So for a while it's going up, for a second or two it goes up, and then after 3, 4, 5 seconds it's falling back down and eventually hits the ground. Okay, so on my graph here, where I usually have x's, they have t's, and they told us t is for time. So as time goes by, we're tracking the distance or the height of the ball. Okay. Now notice this is in the ax squared plus bx plus c form, and our c value is 96. So I know this parabola will hit 96. I know it's a frowning parabola because the a value is negative. So at first, the first couple seconds, the ball goes higher, and then as time goes by, the ball eventually falls back down. Okay? They want to know, when will the ball reach its maximum height? Oh, maximum. That's the vertex. So I need to find that vertex. And I find the vertex by doing negative b over 2a. b is 80, so negative 80 divided by 2 times negative 16. So negative 80 divided by 2 times negative 16. And I got 2.5. Okay? So what that means is 2.5 seconds after we throw the ball, it's going to be at its highest point. So part A here, when will the ball reach its maximum height? 2.5 seconds after we throw it. Second part, find the maximum height of the ball. In other words, this vertex is at 2.5 comma something. What's the something? The something would be the y value or the height. So I'm going to take this equation, this s of t, and I'm going to put 2.5 in for t. So negative 16 times 2.5 squared plus 80 times 2.5 plus 96. I'm going to type that in my calculator. And I got 196. So that means at 2.5 seconds after we throw it, the ball will be at its highest point, and that highest point is 196 feet in the air. And then the last part, after how many seconds does the ball strike the ground? Well, if this is the ball, it goes up for a while and then it falls, then that spot right there is where it hits the ground. Okay? Now, if you think about this point right here, we don't know what the time is. That's what they asked us to find, after how many seconds. So find the time. But when the ball hits the ground, can you agree that its height above the ground will be 0? So they want us to find time when the height equals 0. So we're going to put 0 in for y. 0 equals negative 16t squared plus 80t plus 96. Okay, now this is a quadratic equation. There will be 2 answers. Okay, but only this answer will make sense, because this answer over here will be negative time. That's before you threw the ball. Okay, so that answer won't make sense. So we're going to get 2 answers, but only the positive one is going to make sense for us. 2 ways to solve this. We could try factoring, or you could do quadratic formula. I will let you know this factors. They typically do. In fact, it's got a GCF of negative 16. 80 divided by negative 16 is negative 5. So negative 16 times negative 5t would make the 80. And then 96 divided by negative 16 is negative 6. So negative 16 times negative 6 would be positive 96. If you struggle with factoring, you can plug these into quadratic formula. A is negative 16, B is 80, C is 96. All right, so negative 16, this will still factor. T times t is t squared. Minus 3, no, it's going to be minus 6 and plus 1. T squared plus t and minus 6t is minus 5t. Negative 6 times positive 1 is negative 6. So if these 3 things multiply to make negative to equal 0, then either negative 16 equals 0, I don't think so, or t minus 6 equals 0, or t plus 1 equals 0. Well, if t minus 6 equals 0, that means t is 6. If t plus 1 equals 0, that means t is negative 1. So sure enough, either 1 second before he threw it, the ball was on the ground, or 6 seconds after he threw it, the ball was on the ground. I don't think it was back in time before he threw the ball. So I'm going to say 6 seconds after he throws it is when the ball would hit the ground. Okay? A couple other word problems here on the back. CC owns a hot dog stand. He has found that his profit is represented by this equation. Note it's a quadratic. Note it's got a negative out in front of the x squared, which means it's going to be opening down. Okay. And that C value is negative 300, so that's how I knew that was there. Okay. with P being the profits and X the number of hot dogs sold. Okay, so on my X-axis I've got hot dogs, and on the Y-axis I've got profit. Okay, now they never tell us to draw this picture, but I think it helps. So notice what happens. As he sells more and more and more and more hot dogs, his profit's going to go up and up and up and up. But eventually, he will reach a point where if he continues to sell more hot dogs, his profits will actually decline. And at first you go, well, that doesn't make sense. If he sells more, he should make more money. But here's the thing. If he sells too many, he might end up having more expenses. Like maybe he has to go and hire more workers, or he has to go and pay for more mustard and ketchup and whatnot. Okay, so eventually he reaches kind of a sweet spot where that's the ideal number of hot dogs for him to sell to get the highest profit possible. Okay, and they want to know the number of hot dogs he needs to sell to maximize that profit and the max profit. That word max is kind of our clue that we're looking for the vertex. To get the max, we do negative b over 2a. Our b value is 40, so negative b is negative 40. Our a value is negative 1. So negative 40 divided by negative 2, we're going to get 20. So 20 hot dogs is on our x-axis, 20 hot dogs is the magic number. If he sells 20, he'll get his maximum profit. And then what is that maximum profit? Well, we need to find P of 20. So negative 20 squared plus 40 times 20 minus 300. Notice I'm squaring the 20 and then the negative applies. It's not negative in the parentheses with that 20. And I got 100. Okay, so here's what that means. 20 hot dogs, because 20 hot dogs is on the X. 20 hot dogs will give a max profit of $100. Okay, because that max value was our Y value of profit was 20. Profit is 20 hot dogs, and then the highest the profit will go is 100. Okay. All right, number 14 is similar. Manufacturer of a CD player has found that the revenue in dollars is found by this equation, where P is the unit price in dollars. So if they set the price P to maximize revenue, what's the maximum revenue? In other words, what should they sell their items for? What should they set the price of the CD player at so that they can get the biggest revenue possible? Okay. Again, we have a negative A value, so it's opening down, okay? And the maximum revenue is the total amount of money you bring in, okay? So negative B over 2A. B is 1,600, so negative B is negative 1,600 over 2 times negative 4. So we've got negative 1,600 divided by negative 8. We get 200. So they should charge $200 for a CD player in order to get the highest possible revenue, and the highest possible revenue will be R of 200. So I can type that in. Negative 4 times 200 squared plus 1,600 times 200. And that's $160,000. So if they charge $200 for a CD player, which seems like a lot to me, so maybe they're really nice. If they charge $200, they will maximize revenue at $160,000. If they charge less than that, if they charge $190 or $150, their revenue will be lower. If they sell more than that, if they charge more than that, $210, $220, their revenue will be less. Probably because if they charge more than $200, less people will buy it, so they won't sell as many and make as much money. Okay? And then 15, last example here, another business example. The marginal cost of a product can be thought of as the cost of producing one additional unit. For example, if the marginal cost of producing the 50th product is $6.20, then it costs you $6.20 to increase production from 49 to 50 units. Okay? So to make the next item, it costs them $6.20. Greenway Golf Company has determined that the marginal cost of manufacturing X big boy golf clubs can be expressed by this function. how many golf clubs should be manufactured to minimize the marginal cost. Now notice they said minimize. That's still a vertex word. Maximize and minimize are still vertex words. If you look at this equation, notice that the A value is positive. That means the parabola is smiling. So I have a smiling parabola. So X is how many clubs do you make? And the Y value is the marginal cost. So notice what happens. If you increase the number of clubs you make, for a while your cost goes down. It costs you less money to make them. But eventually, if you keep going, your cost goes back up. Probably because you have to buy, more factories or more people to work there, whatever, and so your cost goes back up. So they want to minimize the marginal cost. So we're still looking for the vertex. Negative B over 2A. B value is negative 16, so negative B is positive 17.4 divided by 2 times A. A is 4.9. So 617.4 divided by 2 times 4.9, and I get 63. So 63 is our magic number. They should produce 63 clubs to minimize their cost. And then we plug 63 in for X to get what that cost is. And we just type that in our calculator. 4.9 times 63 squared minus 617.4 plus 19,600. And I have a typo somewhere. 4.9 times 63 squared. Oh, I left my, there we go. I left my 63 out right there next to the 617.4. That's better, 151.9. Okay, so what does this mean? They must sell, or they must produce 63 clubs to minimize cost. The lowest cost is $151.90. That would minimize their cost. Okay? All right, so those are some good examples. I think they will help you in your 3.1 homework.